Right, so first of all I'll just show you how to do to calculate the yield strength. So the formula that you need for calculating stress, and this is called nominal stress or engineering stress, and what it assumes is that the stress is uniform throughout the thickness of the material, where in reality it wouldn't be. But we're going to use this formula for this, and this is the normal formula to sort of use for this type of calculation. So you've got stress, sigma, which is this funny Greek letter here, equals force divided by the area. So what we want to do is work out the stress that caused the material to yield. So if we go back to our graph, what I've done is I've just picked some random values, which obviously won't be the same as what you've got, just to show you an example. So first thing we need to do is identify the force required to yield the material. So if we look back at our graph over here, then this yield point here, which is quite not, it's not going to be 100% accurate. All you've got to do is find the end of the straight line. As soon as it starts to go curve, that's when plastic deformation occurs. So I've read off my graph, gone across, and it's about 1,000 newtons, I've said. So that's the force. So once I know the force, then the other part of the formula is the area, and that's the area of the specimen itself. So what you'll have done when you did the tensile test was you'll have looked at the box and it told you the nominal diameter of the specimen, which I think is 5 millimeters or something like that. So obviously if you know the diameter is 5, let's say, then the area of a circle, if you don't know that, and you should be shocked, but is pi r squared. Okay, so put your radius value in, square it, times it by pi, and that'll give you the area. What you need to do really though is, because you want the stress value when you work out that particular calculation, you want it in newtons per meter squared. So that means the force must be in newtons and the area must be in meters squared, because then it converts quite nicely to megapascals, which we'll talk about in a minute. So what I've done is I've taken a random area, I've just made it up. I've said the area was 10 millimeters squared when I worked it out, so that is 0.00001 meter squared. So the conversion from millimeter squared to meter squared is to divide by 1,000,000. The easiest way to do it, without doing that really, is just to change your diameter value into meters before you work out the area. So once you've worked out the area and you've identified the force, then all you need to do is put in the values. So we've got 1,000 divided by 0.00001, and then you get your answer, which is something like massive. Okay, I get an error. Right, so we get 100 million. So that's newtons per meter squared, because the force was in newtons and the area was in meters squared. But normally if you look at stress values, if you look at a material chart for a particular material, then its yield strength will be in megapascals or meganewtons per meter squared. So 1 meganewton per meter squared is the same as 1 megapascal, like that. So 100 million, mega means a million, so 100 newtons per meter squared is 100 megapascal. So all these values, when you work out the stress, UTS in a minute, the stress value should be in the hundreds. If you've got thousands or tens, then you've gone wrong somewhere. So they should all be in the hundreds. Okay, hopefully that's clear.